defects in solids. So let's discuss about defects in solids. We up to now we studied about crystalline solids. They may be made up of ions, molecules, atoms. But among all these, what is the major thing present? Because that one is regular or disciplined arrangement of particles will be present. Regular arrangement of particles, and that too for long range is present. If we consider like this, so regular arrangement for a long range is present. This is perfect crystal lattice. But if any atom or ion or molecule lost from this pattern, anything is lost from this pattern by any reason, then that is called defect in solid. Or else we can say there is something change happens in the pattern. Then that will show the different physical properties or different chemical properties. That means defect. That is the basic definition of defect. If at all anything is lost from this pattern, then that solid shows some defect. So let's find out what are the defects. Majorly two sort of defects are present. One is point defect and the other one is electronic defect. Or else we can say this one as atomic defect also. Point defect or atomic defect and electronic defect. But this atomic defect is further divided into three types. Stoichiometric defect, non-stoichiometric defect, and impurity defect. Impurity defect. First of all, defects are divided into two types: point defect or atomic defect and electronic defect. This atomic defect is further divided into three types: stoichiometric defect, non-stoichiometric defect, and impurity defect. This stoichiometric defect will further divided into four types: valence defect, second one is interstitial defect, third one is Schottky defect, last one is Frankel defect. Frankel defect. So first of all, what do we mean by stoichiometric defect? In general, stoichiometric defect, stoichiometry means if at all we balance any equation, the same number will be present on both of the equation. Then that is stoichiometric or stoichiometric coefficient. If we balance any equation with some number, then that is stoichiometric coefficient. Then that ratio will not change when, if at all, any defect also arises. And that too, these two defects occur in non-ionic compounds and these two occur in ionic compounds. Let's see one by one. And that too, this non-stoichiometric also divided into two types: metal excess defect and metal deficiency defect. So let's see one by one. First one is stoichiometric defect, and in that valence defect. And that too, one more name is there for this stoichiometric defect, that is thermodynamic defect. We can see the defect according to temperature. If temperature is changed, the defect is also changed. So let's see one by one. What is vacancy defect? Sorry. Vacancy defect. Vacancy defect. So first one is vacancy defect. Okay, this is our crystal. This is our crystal. And these are occur in non-ionic compounds, non-ionic solids. This is our perfect crystal without any defect. But in this crystal, if any solid is vacant, any solid place is vacant, this place is vacant. When in a non-ionic solid, some of the lattices are vacant, some of the positions are vacant, then that is called vacancy defect. This is vacancy defect. This because loss of lattice, defect is erased. So that sort of a defect is known as vacancy defect. So what is the effect of this defect on density? Density obviously decreases. As one of the solid from this lattice is lost, density is obviously going to decrease. This is about vacancy defect. One of the solid from the crystal lattice is lost, and that defect is known as vacancy defect. This is shown in non-ionic solids, and due to the loss of this solid, density decreases. Then next one is interstitial defect. Interstitial defect. This is also shown in non-ionic compounds, non-ionic solids or non-ionic crystal. Then what happens here? Okay, this is our crystal. Crystal lattice with some solids inside it. When this solids undergo some rearrangement and occupy the interstitial positions. Some atoms occupy the interstitial positions, means internal rearrangement if it happens, means instead of this solid, if it goes and occupies this some interstitial position, undergoes some sort of a rearrangement and goes and stays in the interstitial position, then that sort of a defect is known as interstitial defect. Within the crystal lattice, arrangement occurs. Whether density is going to change in this case? No, density will be same in case of this crystal and in the defected crystal also, because no solid goes out from this crystal. Internal rearrangement happened and this solid goes and stays in the void place. Then no change in case of density. Density will be same. Then the next one is Schottky defect. This is same as that of vacancy defect. But the only difference is this defect occurs in ionic compounds. When equal number of cations or equal number of anions removed from the crystal lattice by any means. So such sort of, then the stoichiometric ratio also does not change, because same number of cations and same number of anions are going out. Then that should be called as Schottky defect. And this is occurred in ionic compounds. So if we consider crystal like this is before defect. If equal number of cations, so if at all equal number of cations or equal number of anions are going out, equal number of cations lost here, and in the same way either equal number of anions will goes out, then that defect is called as Schottky defect. Then what about the density? Obviously density going to decrease, because equal number of anions or cations are going out of the crystal, so density is going to decrease. So same that of vacancy defect, but the only difference is this one is in non-ionic solids and this is in ionic solids. Then the next one, last one is Frankel defect. This is same that of interstitial defect. The only difference here also is ionic compound. It also occurs in ionic solids. When one cation or anion occupies the interstitial positions, then that defect is known as ionic defect. Means same thing, same like that of interstitial defect. This is our crystal before defect. Either one cation or anion rearranges and goes into interstitial position or internal rearrangement occurs, then that sort of a defect is known as Frankel defect, usually seen in ionic compound. Then what about the density? Density remains same, because no loss of anion or cation happened here. So these two are same. These two are same. Vacancy defect and Schottky defect is same, and interstitial defect and Frankel defect is same. Only thing is, though these things have occurred in non-ionic solids and these things happened in ionic solids. So to occur Schottky defect and Frankel defect, some conditions are needed.